value of an annuity. Jasmine purchases a $1,200 computer with a $500 down payment and repays the balance with equal monthly payments for 2 years. We know that the interest is 15% compounded monthly. So first of all, we have to find her monthly payment. That involves using the present value of the loan formula, R times 1 minus 1 plus I to the power of negative n all over I. Most important part of this formula is the negative n. So back to the previous slide, I should have highlighted that as well. The negative n in the exponent, that's a negative number. So really pay attention to that. If you forget it on your test or exam, it will really cause a lot of problems. Okay, the reason why this question is a little bit difficult because we can't simply substitute the $1,200 as my present value. We have to take into consideration that she's making a $500 down payment on that day. So the actual value of the balance that we owe, that's going to be $1,200 minus the $500 down payment and that's going to be equal to $700. So the $700 is what I'm going to substitute into the present value of my loan. And what we have to solve for is the R. R is what I'm trying to solve for. I can figure out everything else that I need to substitute in the formula. My I is going to be equal to 15% divided by 12. So that means my I is going to be equal to 0.0125. This is a decimal. And my N is going to be 2 years multiplied by, repays the balance 2 years multiplied by 12 monthly payments. So N is going to be equal to 24. Okay, these are the values I'm going to substitute into the formula. So let's try to write it again. 700 is equal to R times 1 minus 1 plus 0 0.0 0.0125 to the power of negative 24. And all of that, to make this a little bit smaller, all of that is going to be divided by 0.0125. And because I don't know the value of R, I'm just going to figure out everything in my brackets and the value of my denominator as well. So 700 is going to be equal to R. If I solve my whole numerator, I'm going to get 0.27802931 divided by 0.0125, and that's going to give me a final answer, 700 is equal to 20.62423 R. Because I'm solving for my monthly payment, I have to divide both sides by the value attached to the R, 20.62423. And that gives me a final answer of R is equal to 33.94. So finally, in order to pay off her computer, she has to make payments of $33.94 per month.
Part B of example 7, how much interest did Jasmine pay in total? This is going to be a little different from what we did last time. Let's set that up first. Interest is going to be equal to, now last time we had the final value, but we don't know exactly what the final value is. What we do know is that the final value is going to be equivalent to 24 payments. The reason I'm throwing out that number 24 is because I have compounded monthly for 2 years. So that means 12 payments in the first year and 12 payments in the second year. So that's going to make a total of 24 payments. So 24 multiplied by the amount of R, and we have to subtract from 24R the present value of the computer. So now remember, the present value of the computer is going to be $1,200 minus $500 down payment. So my present value is going to be $700. So my interest is going to be equal to 24 multiplied by my monthly payment. And in part A, I found out that my monthly payment is $33.94. Let's try to write that. And let me just erase this quickly to give me more room. $33.94. So if I punch this into my calculator, 24 times $33.94, that gives me an answer of $814.56. So that's my final amount that I owe, including interest with the computer. Now to calculate the total interest, I have to subtract the present value of the computer. So after I paid my down payment, how much I initially owed on the computer. That was just $700. So the interest that was charged to Jasmine is $814.56 actually, minus $700. That will give me a total of $114.56. So this is what Jasmine owed in terms of interest. The total amount that she had to end up paying after taking into consideration the monthly payment is $814.56. and 56 cents.